In this video, we're going to introduce you to the very important concept of chemical equilibrium. In order to illustrate chemical equilibrium, let's talk about a hypothetical reaction where some reactant A is converted to some product B. So in this hypothetical reaction, we are going to assume that we are starting with some concentration of A but no B. So we're starting this reaction with only A, but no B. So therefore the reaction will proceed, we say, in the forward direction. So A will be converted to B initially. Now I want to, before I move on, I want to point out an important point. Chemical reactions do not always begin by proceeding in the forward direction. If you have a high concentration of product at the beginning, the reaction may move in the reverse direction. And we'll talk about how to determine the direction the reaction will go initially later on in the chapter. So anyway, let's consider this hypothetical reaction. A is converted to B. We have some initial concentration of A, and our initial concentration of B is 0. Okay? So once we begin the reaction, since the concentration of A is large relative to the concentration of B, which is 0, the rate of the forward reaction will be fairly fast. And there will be no reverse reaction because we have no product initially. Okay? So remember, collision theory tells us, in general, the higher the concentration, the more likely a collision is. And so the more rapid that reaction, or the more likely that reaction is to occur, and therefore the faster the rate. Okay, so initially we have a fast forward reaction, and the rate of the reverse reaction is 0. Now, as the reaction proceeds, the conditions change, and so do the rates. The concentration of A will begin to decrease over time, so with fewer A molecules, the rate of the forward reaction will begin to slow down. As we begin to build up our concentration of product B, then B will begin to react to reform A. In other words, the reverse reaction will occur. So this is true in almost all reactions that have a forward reaction. The reverse reaction can also occur where the products react to reform the reactants. So the rate of the forward reaction begins to slow as the concentration of the reactant decreases. The rate of the reverse reaction begins to speed up as the product begins to build up. Now, as the reaction continues, eventually we get to a point where the rate of the forward reaction slows and the rate of the reverse reaction speeds up until those two rates are equal. At this point, we have reached what we call chemical equilibrium. In other words, every time a molecule of A is converted to product or to form B, every time A forms a B molecule is converted back to A. So at this point, the rates of the forward and reverse reactions are equal, and therefore the concentrations of A and B are constant at equilibrium, because every time we lose a molecule of A, a molecule of B converts to reform A. So these concentrations remain constant. However, very important to note, at equilibrium, the concentrations of reactants and products are not equal, they're just constant. So be sure that you appreciate what chemical equilibria is, and that you can describe the process beginning with from the beginning of the reaction until equilibrium is reached, and you can explain it in terms of reaction rates and concentrations as we have here.